Good morning, students. Today, another new chapter in beginning. So, that is blood and body fluids. Blood and body fluids has got a lot of significance in crime investigation. So there are so many body fluids. One among the important one is the blood, semen, vaginal secretions, saliva, nasal secretions, sweat and urine. As you know, vaginal secretions are also sometimes very important, especially in all sexual offences cases. Even saliva is very significant, especially from the bite mark area. We can collect the saliva, and within the saliva some epithelial cells are present. So with that also we can take out the DNA, and that will be very useful for the identifying the criminal. Among the body fluids, as you know, the most important one is blood and semen. So today we will discuss in detail about blood and semen. So blood is one among the very important one. You know various aspects of blood. You are already read in your physiology. And in this chapter, we will focus mostly on the various medico-legal aspects in relation to blood. You know, collection of the blood from crime scene area, that is very important. If it is a liquid blood, easily we can pipette out and collect. Or else we can use the filter paper, so that just to soak it in a filter paper or a cotton swab or a gauze piece, and again carefully we can preserve and we can forward to the forensic science laboratory. If it is a dried blood, so it is very easy. Once it is dried, we can scrape off using a knife, and we can collect it. We can also collect the blood stains from even the cloths. So please remember, they are extremely resistant even for washing. Even washing in a bathtubs, that is in washing machine. So still even after that, we can collect the blood stain from the cloth. And one more important thing you have to remember is, we should use a solvent for preserving. So there are various solvents are available. The one among is weak ammonia solution. We can also use glycerin in distilled water as a solvent. And another important one is M.B.B.S fluid. Sodium chloride 2 grams, mercury chloride 0.5 grams, and 100 cc of distilled water. This is called M.B.B.S fluid, and this also can be used as a solvent for preserving the blood. And more important point again you have to remember here is, we should not use the plastic container, because plastic container, the moistureness will be more in plastic container. So that's why the blood will be easily spoiled. So it is always better use a glass container. Okay. So this is very, very important. You should always preserve the blood in a glass container. Okay. So please remember, it is extremely resistant for washing. Okay. Even after washing in a washing machine, still we can recover the blood stain. Okay. And also remember, we should always preserve in a glass container. Coming to the medico-legal significance of the blood. So we are supposed to explain some of the important points. Whether the stain is, first of all, whether it is a blood or it is a something else. Because so many coloring agents, sometimes they mimic like a blood. They look like a blood. So that's why we have to be established first whether it is a blood or it is something else, some other substance. Then once we confirm that it is a blood, then we should also confirm whether the blood belongs to a human or animal origin. We should also explain what is the source of the blood. That means which part of the body the blood collected. And another one is what is the age of the stain. This is another important point. And whether it is an antemortem or postmortem blood we are collecting, that is another important point. And we should also explain to whom does the blood belongs. So we should also explain the identity of the individual. So blood belongs to each person. So these are important medico-legal questions we should answer, okay, whenever we receive a sample of blood. We'll go one by one. As I told you, there are some substances they resembling blood stains. Even some of the vegetable stains, especially fruits, okay, gooseberry, mulberry, jambans, okay, or even some of the other vegetable origin, pawn juice, henna. So these are all coloring like they mimic like blood stain, but they are from vegetable source. Some of the mineral stains, red lead, iron oxide, mercury sulfide, okay. So these stains are also mimic like blood stain. And rust stains. The rust stains which are usually present on the metal, especially on the blades or knives, okay. So again, these stains are also sometimes may similar like blood stain. Okay, rust stains, it is easy. If one end of the metal is there is a rust stain, whenever we have a confusion, the other end we are supposed to heat it. If it is a blood stains, it will easily fall, or else the rust stains are soluble in hydrochloric acid, HCl. So like this we can able to easily identify whether the stain is a rust stain or a blood stain, because especially most of the weapons, they are prepared by some metal, they are prone to rust formation. So sometimes this rust stain one may confuse that it could be a blood stain. So there are other synthetic dyes, okay. Synthetic dye stains are also, they mimic like blood stain, And synthetic dyes, if you add nitric acid, it gives yellow color. So with this we can easily able to identify whether it is a synthetic dye stain or it is a blood stain. There are even other substances like grease and resin substance and also tar substance also mimic like a blood stains. So first of all we have to be differentiate whether it is a true blood stain or it is some other substance which are mimic like a blood stain. So this is very important. You should remember this. Rust stains, some of the synthetic dye stains, mineral stains, some of the vegetable origin stains, and grease, resin, tar like substances, they are all mimic like a blood stain. So we have to identify carefully. So what are the methods we adapted to detect whether it is a blood stain or not? One is examination, okay, by our naked examination, microscopic examination, because as you know the morphology of RBC. So we can examine even under microscope. Then we can also use other techniques like various chemical examinations and some of microchemical examination and spectroscopic examination. These are all various techniques we adapt to detect that the given sample is only blood. So first, naked examination. One is the color. The color of the blood is changing from time to time, because the fresh blood usually it is red, okay, glossy, and after some time it becomes reddish brown in color because of the conversion of hemoglobin into methemoglobin. Arterial blood is always bright red, whereas venous blood is purple in color. Okay, so after 24 hours slowly the color of the blood will be changing, and if you observe after weeks, then it will be completely turned into black. Okay, coming to the consistency, initially the blood is in a liquid because of the mechanism, clotting mechanism. After some time it becomes dry and clot. Okay, so if you found a moist blood stain, it is very fresh blood, and if you found a dried blood stain which is already clotted, so we can able to explain that some maybe some hours to days old blood stain. So like that we can able to explain by our naked eye examination. Coming to the spurting of the blood, especially in the crime scene area, when you observe, always arterial blood bleeding from the artery. So when it is blood oozes, that is from the artery, it is something like spurting, because the blood is in high pressure in the arteries. So that's why whenever there is a cut, and whenever there is an artery cut, so okay, it is something like a spurting, like we can observe. If it is a vein, usually the venous blood, it is something like a oozing. It is not like a spurting. Okay, arterial bleeding is spurting. Venous bleeding is something like oozing. So this is one important point. So if the blood strikes the surface perpendicularly, so this is the most commonly observed in an artery cut. So when it strikes the surface perpendicularly from some particular height, as I told, especially arterial blood, the stain shape is circle. So if height is increases, the edges become little crenated. If the blood strikes the surface in obliquely, okay, if the blood strikes the surface obliquely, the stains are oval in shape, and the bottom narrow end point, which indicates the direction of the spot. So by looking at the crime scene examination, we can easily explain the bloodstains which are present on the walls, sometimes the bloodstains which are present over the roof. This will explain, okay. So based on the position of the body and the bloodstains which are present over the walls or maybe on the roof, we can easily explain. You can see in this photograph, it is spotting almost or striking the surface perpendicularly. That is why you can able to see the circular, almost a circular pattern. If the blood strikes little obliquely, if there is some angle, so you can able to see here perpendicular, almost all like circle. If the angle increases and it becomes something like oval, and of course the one point which is narrowing, you can able to see here one point which is about narrowing, and this will explain the direction. So this is a splashing of the blood on the wall in a oblique direction, so that the bottom portion you can able to see the narrow line, and the top you can able to see oval in shape, and this will explain that the striking of the blood on the wall in a oblique direction. Coming to the source of the blood, if the blood is from the lungs, usually it is a bright red frothy blood. Some amount of the froth is present, and usually it is bright red in color. If the blood source is vomited blood, so vomited blood is always brown color or chocolate color. Because of the acid hematine formation, the blood is chocolate color or brown color. If it is a menstrual blood, so it is something like disagreeable odor, and it is more fluidity because of the increased fibrinolysins in the menstrual blood, so that it is more fluid. And sometimes we can also find some vaginal epithelial cells within the blood. If it is a source of blood is from the nose, usually it is a mucoid, and of course sometimes a nasal hair can also seen in the blood. If the blood is extracted from the boils and sores, it contains pus cells, and it is some amount of bacteria also present, and usually it is a smeared appearance, not a round, it is a smeared appearance. So with this we can also explain from which part of the body that is the blood which is recollected, that is the source of the blood. At the scene of the crime, we can also explain a large pool of blood, okay, only present at the side of the body, okay, or a trail of the blood stains on the ground. So we can able to explain if the body is moved, so that a trail of the blood stains on the ground can be seen along the direction of the movement of the body. So blood stains we can easily see on the ground. At the same place, if the large pool of blood is present in the same place, so that you can able to explain that body originally where it is, and at the same place the body is found. Body was not moved after the death. Sometimes if a accused or if a person place his foot on the blood, and when he walk away, sometimes we can also see the footprint. Similarly, if the person, if he touch the blood, and again if we touch the other objects in the area, we can able to notice the fingerprints. Similarly, footprints. So we can recover from the crime scene area. Okay. If the person involved in that particular crime touch the blood or place his foot on the blood, and he walks away, okay, or he further touch the other objects in the area, we can easily recover the fingerprints. We can also recover the footprints, because blood stains which will easily form a footprint, and this will be useful for the identity of a criminal. Okay, this is also very important point you have to remember. Coming to the cloths, as I told you, we should not use the heat for drying, because heat usually damage the blood stain. So that's why we should not heat dry. Okay, we should only dry it for keep the cloths for some time. Okay, and it dry by automatically. So drying is very, very important. Okay, why we supposed to dry? If the blood is wet, so it may undergo some amount of putrefaction and the blood sample may be damaged. So that's why drying is very, very necessary. So we should just hang up the cloth for drying, and we should not heat dry. So that is very, very important. So based on the blood stains which are present over the cloth, so the underlying injury, usually the corresponding injury we can able to notice. For example, if it is a cut throat during a sleep, the blood which are come out, okay, may present over the shirt collar and the back. If the person is standing, the blood stains on the cloths and body would be vertical. Okay. If it is a sexual assault, the blood stain can be seen, especially in undergarments, okay, and also underwear. So these are the things are very, very important. So the cloths, whenever we found any blood stains, because as I told you, even washing, we cannot able to remove the blood stain. Even after wash also we can recover the blood stains. And most important one is, we should suppose to hang up the cloths to dry, and we should not heat dry. So that is very important. Coming to the microscopic examination, human red blood cells are, they are circular and biconcave. So this is very important. Human, all mammals, the blood RBC is circular, biconcave and non-nucleated. Usually the diameter is 7.2 microns. Exception is only camel. The camel is biconvex. The camel is biconvex. Human red cell is circular, biconcave and non-nucleated. If it is the lower animals like fish, frog or reptiles, again it is biconvex and nucleated. Biconvex and nucleated, all lower animals, whereas in mammals it is circular, biconcave and non-nucleated. Okay, whereas in camel it is biconvex. So please remember, human red cell is circular, biconcave, non-nucleated, and the diameter is around 7.2 microns. We can also recover sex chromatin, especially from the neutrophils. We can recover the sex chromatin. It is called Davidson body. The sex chromatin is called a Davidson body. We can recover. Most commonly, we can recover from the female sex. Similarly, if there is any individual suffering from particular disease, and based on that particular disease also we can able to identify the individual. And another important one is blood groups, also very important for identification. Sometimes we can also do the DNA profiling, and based on the DNA profiling we can easily identify the individual. So this microscopic examination is also very important for identification of the blood stains or blood sample. Coming to the chemical examination, there are various tests are available. So some are presumptive test, some are confirmatory test. So how we are going to be examining this presumptive test is based on the presence of peroxidase in the blood. The one most popular test is Benjamin test. So it is also called as Adler test. So suspected sample, just add a few drops of Benjamin reagent. So the sample turn into blue color. So this blue color is it is positive for blood stain. Okay, so suspected sample, add 2 to 3 drops of Benjamin reagent. The sample turn into blue color. If you add a little hydrogen peroxide, the sample will turn into dark blue color, and this we can explain that it is a positive test for blood stain. So nowadays, because the Benjamin is carcinogen, so that is why most of the laboratory people, they are not doing this Benjamin test. Instead of Benjamin test, they are doing orthotoledine test. So it is also called as Kahn's test. So again same, suspected sample, if you add orthotoledine reagent, the sample turn into blue color. This indicates positive. The another test is a phenolphthalein test, also called Kastle-Meyer test. So phenolphthalein test, if the sample is a blood, it turn into pink color. Leucomalachite green test, if the sample is a blood, if you add a leucomalachite reagent, so the sample will turn into bluish green color. We can also do the fluorescent test. So using the certain dyes, either luminal or fluorescent dyes, most commonly used, and these dyes are sprayed in the crime scene area. Okay, we can easily locate the blood. Okay, some stains which are not visible also, we can easily locate the blood stains just by spraying this fluorescent or luminal dye in the crime scene area. So these are all presumptive tests. So we can explain to an extent that it is blood. Confirmatory test, microchemical test. So these tests are based upon hemoglobin molecule. So with this we can able to identify. There are two important tests. One is Hemin crystal test, also called as Teachman test, because this test was invented by Teachman, Poland. So add small crystals of sodium chloride and glacial acetic acid to the suspected sample. If the suspected sample is a blood, so it turns into yellowish red crystals. So that is positive. And another test is hemochromogen test. It was invented by Takayama of Japan. That's why it is called as Takayama's test. So hemochromogen test. So add Takayama reagent. So this is a saturated glucose, sodium hydroxide 10%, water, distilled water, and pyridine. This is Takayama reagent. If the sample is a blood, it forms pink feather crystals. That is positive. So these two tests are more confirmatory test for blood sample or blood stains. Coming to the spectroscopic examination, this is another important confirmatory test, and it is most sensitive test, most delicate test. Okay, so we can identify even the recent blood stains, or even we can identify even the old blood stains. Okay, so certain proteins, especially hemoglobin and its derivative, it absorbs light and produce a characteristic absorption bands. Okay, so when the suspected sample, take it in a test tube and pass the light. Okay, and this sample absorb this light, the proteins which are present in the blood sample absorbs the light, and this emitted light should be again passed through the prism, and this will form the spectrum. So this spectrum of different wavelength bands, okay, thick thin line bands, based on this we can easily identify that the sample is blood. Most delicate, most sensitive test. So we can also write, once we identify the blood, then the question arises whether this blood belongs to the human or whether it belongs to the animal. So we do various immunological tests. One is a precipitin test, antiglobulin consumption test, gel diffusion test, double diffusion, precipitation electrophoresis test. These are all immunological tests, and these tests are useful for identifying whether the blood belongs to the human origin or whether it is from the animal origin. So the most popular test is the precipitin test, is the most popular test. With this we can easily identify whether it is the human origin or it is an animal origin. So how we perform the precipitin test? So as you know, the blood serum contains some proteins. Okay, so when you inject this human serum into animal, the animal becomes immunized against this serum, okay, because which contains some proteins, and develop antibodies. The animal develops some antibodies. These antibodies are called precipitins, and the serum we extract from the animal, that serum is called anti-human precipitin serum. So human serum inject into the animal, and animal will develop antibodies called precipitins, and we extract the serum which contain antibodies. That serum is called anti-human precipitin serum. So if a suspected sample, if it is a human serum, okay, brought into contact with anti-human precipitin serum, okay, the two would react and form a visible precipitate. So if the precipitation occur, okay, with anti-human precipitin serum, the suspected sample serum, when it is react with anti-human precipitin serum and precipitation is formed, then we can confirm that it is belongs to the human origin. So this precipitin test is a very useful test to detect that the blood is from human origin. Coming to the age of the blood, as we discussed earlier. So usually fresh blood is moist and sticky, and it is fluorescence more because it allows the light to pass. Fluorescence more. As you know, arterial blood is bright red and venous blood is dark. Okay, if it is a fresh blood, it is moist and sticky and it fluorescence more. And 24 hours, okay, if the age is 24 hours, one day, around one day, it turns into reddish brown or chocolate in color. It is stiff, okay, because it clots, the blood is clots. If it is on the surfaces, something like in a metal or any plastic surface, okay, the stain will crack, some fissures or cracks are seen on the stains, okay, and it is less fluorescence because of the increased hematine levels. So with this we can able to identify it is 1 day old blood. If it is few days old, the color will become brown in color. After several weeks, it turn into black in color. So with these changes, we can able to identify the age of the blood stain. And another important point is whether this blood stain we recovered, whether it is an antemortem or whether it is a postmortem origin. Very important point. Antemortem blood effused during life, okay, because antemortem blood, it will be easily clotted, okay. So that is why the dried blood we can remove in scales because it consists of a fibrin. That is why it can only remove like a scale. Whereas postmortem blood, it does not contain any fibrin. So if a dried sample, if try to scrape it, it break up into a powder. So this is why, this is how we can able to easily differentiate whether it is an antemortem or whether it is a postmortem. Remember, antemortem blood, dried blood can be removed like a scale because it consists of presence of fibrin. Postmortem blood, it break up into a powder. And another important point is to whom does this blood belongs to, identification. So there are various techniques. One is blood grouping. So with this blood grouping technique, we can easily identify the blood belongs to whom. And more specific is a DNA fingerprinting. So with this DNA technology, okay, we can take out the DNA from the WBC. So with this DNA technology, we can easily identify the individual who belongs to. So there are two, one is blood grouping, another one is DNA fingerprinting. So compared to the blood grouping, DNA fingerprinting is the most specific test for identification. So blood grouping, as you know, based on the red cell antigens, there are various blood group systems are available. So one is a M.B.B.S system, the most commonest system which we are adapting. So based on the red cell antigen which is present, A group, B group, AB or O group. Similarly, M.B.B.S system, and another system is RH system. If it is present, we call RH positive. If it is negative, we call RH negative. K system, Kell system, then Duffy blood group. So these are all useful for the identity of individual to certain extent. And another important system, that is HLA system, okay, leukocyte antigens. They are polymorphic glycoproteins which are present over the WBC cell wall. So certain extent we can also useful, this HLA system are also useful to certain extent it is identification. But you know, after DNA fingerprinting, because DNA is most specific, see nowadays DNA fingerprinting is most commonly used for identification. Coming to the various medico-legal importance of blood groups. So, the one is very important, one is to explain disputed paternity, sometimes to explain any disputed maternity. It is useful in crime investigation and very useful to identify a person, and it is also sometimes useful to explain the cause of death. We'll see one by one. Disputed paternity. There are some circumstances, some kind of disputed paternity will arise. Like when a child is born in unlawful marriage, but the husband denies to be the father of the child. So if a person denies that he is the father of that particular child, this is a disputed paternity. In lawful marriage, the mother accuses a certain man of being the father of the child. In another circumstance, when a woman pretends to pregnancy and delivery and obtain a child, claiming that he is the own in order to obtain some property share, husband property share. So this is another dispute. Sometimes in nullity of marriages, sometimes a suit filed regarding nullity of marriages. So these are the circumstances where in a disputed paternity, the blood groups are also sometimes useful to explain. There are certain limitations, right? So we cannot able to definitely establish, okay, that the person is the father. Okay, the positive blood group, if the child blood group or parent blood group is same, we can only tell the possibility. But this is more definitely we can explain to certain extent. If the blood group is negative, it is more significant. Okay, the negativity is more significant than the positivity. Okay, but it has got its certain limitations. Coming to the disputed maternity, there are certain circumstances where most commonest is accidental exchange of babies in the hospital. When the same child is claimed by two women, and this kind of circumstances are very, very common in the society. Two mothers will claim one child belongs to them. So this is very commonest circumstances we used to come across in the society. One single child claimed by two women. Accidental exchange of babies in the hospital. Suppose it was child born after death of the parent. In case of a kidnapped child, when the woman has kidnapped the child and claims to be the mother. So in these cases, like disputed circumstances, disputed maternity, also to be explained to certain extent by using blood groups. So what are those? We'll see. If both the parents' blood group is O, the possible blood group of the children is only O. Impossible A, B and AB are impossible. So this is very, very important one. If both the parents' blood group is O, the child blood group must be only O. So A, B and AB impossible. So like that we can able to easily identify. So negativity is more significant than the positivity. If the parent blood group is O and A, okay, parents blood group is one is O and another one is A. The possible blood group in children are O and A. Impossible are B and AB. Similarly, parents blood group is O and B. The possible blood groups are O, B possible in children. Impossible are A and AB. If the parents blood group one is O and another one is AB, the possible blood groups in children is A or B. Impossible are O and AB. If both the parents are A blood group, then possible in children is O or A. The impossible is B and AB. If the parents' blood group is one is A and another one is B, the possible blood group in children is all the blood groups are possible. O possible, A possible, B possible and AB possible. Impossible is none. If the parent blood group is A, one is A and another one is AB, the possible blood groups of A possible, B possible and AB possible. The impossible one is O. And if both the parents have B blood group, the children's possible blood group is O or B and impossible are A and AB. If parents' blood group is B and AB, the possible is A, B, AB are possible, O is impossible. If the parents' blood group is AB and AB, the possible blood groups in children are A, B and AB and impossible is O. So, negativity is more significant than the positivity. Okay. So, if O and A parent, the child blood group is imagine a B, definitely we can say this child is not belongs to the particular biological parent. So, if the child blood group is either O or A, the possibility can be certain extent only explained. Okay, it may be possible, but not definitive. But we can say here, negative sense, if the child is B or AB, we can say definitely the child not belongs to the parents. So like that, the negativity is more significant than the positivity. Coming to another important body fluid, we recover from the body and also from the crime scene area, that is semen. Examination of the semen is very significant, especially in sexual offences cases. You know, semen also, there are other substances which are mimic like a semen. One is the starch, okay, the stains of the starch. Similarly, pus, okay, the stains of the pus. Leucorial discharge, okay, there is vaginal discharge, it's called white discharge, leucorial discharge. Egg albumin. So these stains are also mimic like a semen stains. Sometimes it is a confusing whether it is a semen stain or belongs to some other stains. So how we are going to be identified? Again, the one important one is physical examination, chemical examination and microscopic examination. So this will be useful for explaining whether the suspected sample or stain is a semen. Physical appearance. Seminal stains are greyish white or yellowish grey, jelly-like, sticky fluid. Greyish white or yellowish grey, jelly-like, sticky fluid. It has got a very characteristic odor and it is a rich content of fructose. It stiffens the cloth like a starch. Fresh stain is more translucent. If it is old, it will be turned into yellow to brown. Okay. So under ultraviolet rays, it appears bluish white in color. So these are the physical characters of semen. Coming to the chemical examination, there are various tests are available to detect it. The one is the Florence test. It detects the presence of choline. Okay, so we add a Florence reagent. So if the suspected sample is a semen, it produces brown rhombic crystals. Another important test is a Barberio test. So when we add a reagent, so yellow needle-shaped rhombic crystals are formed if the sample is semen. Another important test is creatinine phosphokinase test. So semen has a very high concentration of creatinine phosphokinase, which is an energy reservoir. Okay. So when you add alpha-naphthyl phosphate, it gives purple color. So this is one of the presumptive tests because Creatine phosphokinase is also present in various other body sample, so that is why we cannot take it as very definitive test. It can be only a presumptive test. And another important one is acid phosphatase test, very important test, acid phosphatase test. So this acid phosphatase is highest concentration is seen in prostatic secretion. Semen contain very high concentration of acid phosphatase, what is called as seminal acid phosphatase, very significant test. So if we found, we can easily explain that it is the sample is semen. Okay, and sometimes we can also recover this acid phosphatase from the vaginal secretions, and based on this we can also explain the approximate time of intercourse, sexual intercourse. So usually if it is within hour, the levels of acid phosphatase levels are very high. So after 24 hours the levels are very low. So based on the levels of concentration of acid phosphatase in the vaginal secretions, we can able to explain even the approximate time of sexual intercourse. And other technique is immunological technique, also useful for examination of semen. Coming to the microscopic examination, it is the most definitive test. And if you found even one spermatozoa from the vagina, and it is very confirmatory positive test, we can establish that it is in a case of especially in sexual offences cases. And we can also recover the spermatozoa, and of course the spermatozoa which has got three parts like head, neck and body, and there is a tail portion. So a nucleus present in the head, so which consists of chromatic material. So this based on this we can also make out the DNA profiling. So with that we can easily identify the individual. So this is very useful for confirming, especially the confirmatory. So we have to take a smear from the vagina, and we can examine directly under the microscope. So with this technique we can easily identify. So usually the staining is we do methylene blue, and of course we can also do the staining with eosin and hematoxylin. And head portion, which will be appear deep red or pink, whereas the tail portion appear pink in color. So this identification of the sperm is more confirmatory that the semen, it is a sample of semen. But you should also remember, in certain cases the sperm may not be identified, especially if the vasectomized individual. If the criminal already vasectomized, so it is a difficulty to extract the sperm. That is one important one. Or sometimes if the criminal used a condom, so again it is difficult to extract the sperm. So in the vagina, usually the motile sperms are seen up to 1 to 3 days, in the anus up to 2 days, in the mouth up to 9 hours. So the sperms separate into head and tail, because it may break, the head and tail may break. Usually after 1 to 3 days it may break, so that the complete morphological like head and tail like that, it is impossible to detect after 3 days. Coming to the motility, first 3 hours it is fully motile, and it will be decreased to 50% in 8 hours, and 10% mortality can only be seen in 24 hours duration. Some secretors, even from the semen we can make out the ABO grouping, and this will be useful for identification. And various medical legal issues, the semen is important. Civil cases where there is a compensation on the grounds of acquired sterility, disputed paternity cases, legitimacy cases, artificial insemination related issues, and sometimes compensation on the grounds of failure of vasectomy leading to pregnancy. These are all the civil cases where semen examination is significant. Coming to the criminal cases, especially in commission of sexual offence, especially cases of rape, okay, and semen is very useful to identify even the offender, because as I told you, the sperm contains nuclear material, so with that we can make out the DNA. So with the help of the DNA we can easily identify the offender. Okay. So seminal stents are useful, usually found on the clothing of either accused or the victim. Thank you. So other body fluids are not much significant, but whereas the blood and semen is very significant medico-legally, especially in crime investigation. So this chapter is very, very important. Thank you.